Anyone in particular? Any section? Yeah, Claire.
Number 9.
Number 9. Any specific thing about number 9?
After the slope.
After the slope. Okay, so you have two. You want the temperature in terms of the number of chirps per minute. The temperature in terms of the number of chirps per minute.
How do you, like, determine that? Because that was, like, probably the confusing thing, like, knowing which one
I agree.
first. And, like,
We talked about this in the last class, and here's the thing. As a good starting point and a way to complete 99% of it, you can put it in either way. You can put it in either, you can order it either way. The question specifically asks the temperature in terms of n. So you can think about it this way, temperature in terms of blah, 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 something in terms of n. You can think about it that way. But if you reverse the two, if you've done the relationship correctly, both equations should represent the same relationship. How many different ways can you represent the same relationship? How many different ways can I write that same relationship? Tons. In math, there's only 3 numbers. 0, 1, and? What are the 3 numbers in math? 0, 1, and what? In terms of numbers of answers. There's either 1 answer to something, 0 answers to something, or an infinite number. So in this way, how many different ways can you write the same relationship? An infinite number. In general, though, we could write t in terms of n or n in terms of t. They're asking for t in terms of n, but if you wrote it n in terms of t correctly, can you still make conclusions? Absolutely. It might be, the math might be a little different, but should you result in the same answers? Absolutely. They want t in terms of n. T in terms of n. Now, does that mean you write, how would you graph this? What's your input and what's your output? You want t in terms of n. If you want another way to look at this is you want t in terms of n. Do you usually write y in terms of x or x in terms of y? Y in terms of x, exactly. So our coordinates are usually x, y. So in this case, what would our coordinate be? Nt. Is that one way to think about it? Usually like y in terms of x, y equals blah, 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 x. So one way to get it straight in your head is to think about it that way. Just be consistent. And the best way to be consistent is label everything. And use, I'm struggling with this in my other classes, complete sentences. Does that make sense to everybody? So in this case, for this question, maybe nt is the best way to write it. So we had t in terms of n, so our input was, we're writing a function where our input is the chirps. So we had 173 correlates to what? 80, and 113 correlates to, so if we want to write a linear relationship, it's going to be 173 minus 113 over 80 minus, and this is going to be 6, right? Is that 6?
It is.
And that right there is not really a good way to write that slope because I just wrote run over rise. What should I write instead? I'm sorry. 80 minus 70 over 173 minus 113 equals 1 over 6. So please start using this. Start there at least. So what do you have? Y minus, I don't know. Oh, not, well, in this case, instead of y minus y1 and x minus x1, what are you going to write? Is it t or n? Yeah, we wrote it nt, so it's t minus equals m times, yeah, so in this case it's going to be t minus, and which point are you going to use? You can use either one. I like smaller, it doesn't really matter. Will you have the same equation no matter which one you use? You should. I would pick this one. T minus 70 is 1/6 times n minus 113. Is that right? If they want t in terms of n, they generally want t to be isolated, generally speaking. So t in terms of n is going to be 1/6 n minus 113 over 6 plus 70. You could simplify it a little bit. T equals 1/6 n 420, so it's going to be plus 420 minus 113 over 6. So t is equal to 1/6 n plus 307 over 6. So that is t in terms of n. Could you reverse it, make it n in terms of t? Sure. Can you make similar conclusions? Can you analyze this data in the same fashion? Sure. You just have to plug things in different places. Well, actually, you're plugging them into the same place. It just might look a little different what's going on around it. So then C asks, what does this slope represent? That's a great question. Can someone tell me what does that slope represent? Okay, in terms of this question, can someone use a complete sentence to tell me what the slope represents? Yep. So the temperature, you can write it like this. I'll give you a start. The temperature increases by what? By 1/6 degree Fahrenheit for every additional chirp per. Yeah. The temperature increases by 1/6 degree Fahrenheit for every additional chirp per minute. In the natural world, this means if you were listening to a cricket chirping, what could you predict? Or you could tell what the temperature was. What's one challenge to that?
There's a lot of crickets.
A lot of freaking crickets, right? So unless you have like this one cricket you bring outside, like, here's my thermometer. Look at the cricket for a minute. Hey, temperature, I know what it is. Otherwise, it's kind of hard to count one specific cricket, right? If the crickets are chirping at 150 chirps per minute, estimate the temperature. So that's going to be T of 150. So that's going to be 1/6 150 plus 307 over 6. So that's going to be what? So around 76.5 degrees Fahrenheit. Yeah. Okay, any other questions on the non-stock portion of this homework assignment? The non-stock portion of this homework assignment.
11.
Number 11. At surface area, let me just clip that in. Number 11. Oh, that's not what I wanted. At the surface of the ocean, the water pressure is the same as the air pressure. What would happen if the water pressure wasn't the same as the air pressure? Oh, come on, kids. At the surface of the ocean, the water pressure is the same as the air pressure above the water. What happens if the pressure wasn't the same? What? No, but what happens? What happens if the air pressure was different than the water pressure? What would happen then? Or compress. It compresses to an equilibrium, right? Something would happen. The equilibrium would change in some fashion. Below the surface, the water pressure increases by 4.30 pounds an inch square for every 10 feet of descent. Express the water pressure as a function of the depth below the ocean. So this is going to be the water pressure in terms of depth. So think about this, y in terms of x. So we have water pressure at a depth of 0 is what? At the surface. It's in the question, everybody. Take a look at the 15. So there's our first point. What would be our second point? 10 feet and 4.34. So this would be our water pressure. We'll call it water pressure, and this is our depth. So what do we need in order to write a linear equation? Oh, it's not. It increases by. Sorry, increases by. So what is it going to be? 19. Sorry. My fault. 19.34. Right? So 10 minus 0 over 19.34 minus... I mean, it already told... So what is it going to be? 10 over 4.34. So we end up with D minus... What point do you want to use? This one or this one? Well, D minus 0 is equal to 10 over 4.34 times water pressure minus what? 15. Oh, we reversed this. I'm sorry. We want water pressure. I'm sorry. My fault. My fault. I'm doing this a little too quickly. We wanted water pressure in terms of, you see how easy this is to make a mistake on? I just reversed it. We want water pressure in terms of depth, right? So what's our y? I wrote it up there first just to avoid this problem. So how should I have written these? How should I have written these coordinates? Yeah, instead of dWp, what should they be? They should be d water pressure, right? So the depth is 0 and it's 15. The depth is 4.34, so the depth is 10. So it should be 3.4 exactly. So now when we actually write this slope, what's it going to be? 19.34 minus 15 over 10 minus 0. So it's going to be 4.34 over. So it's going to be 0.434. So now what do we have? Water pressure minus 15 is equal to 0.434 times the depth minus 0. That's why we picked that point. Picking points with 0 in them helps. So what's our water pressure in terms of D? 0.434 D plus 15. Go to lunch and we'll talk about this when you get back. Okay, so what did people discover about Google? When they looked at Google stock, what did you discover? Can someone tell me one thing they discovered about Google stock? Raise your hand. Yeah, go ahead.
It's less reliable. It's more reliable.
Liable than what?
It's less reliable than Apple.
Apple stock. What do you mean by that?
The graph is more erratic, so it goes down more than
The graph
and Apple, which is the
of stock price over time is more erratic. Great. Okay. Somebody have something else about Google stock? Something different? Yeah.
I felt like, except in 2008, they generally like went up towards the end, like the prices.
Except in 2008, the price generally went up at the end.
Yeah, like or people were buying more stuff.
Got it. Something else about Google. Something else. Whole class is supposed to analyze this. Yeah.
the overall value is probably double than Apple.
The overall value of the company.
Yeah.
Overall value of the company appears to be double what Apple is worth. Okay. Anything else? No one came up with anything else. I know you have something. There's something out there. Yeah, Claire, go ahead.
I feel like the prices or the amount of stocks like went up and down a lot more than Apple was a little bit more steady.
Yeah. So Apple is more. Less. So it's less reliable than Apple.
Okay.
Yeah, but yeah, it's more steady than Apple. Okay. Anything specific to Google? Anything specific to Google? Anybody do any numeric analysis? No one ran in your. What?
The numbers are greater for Google.
Can you be more specific? I gave you a lot of numbers. The what?
Overall value of the company, but like the lowest the Apple goes is 13.52,
Yep.
and the lowest the Google is 102.
So each share is worth more. So now here's the thing. You have to be very. We'll get to the specifics later, I guess. But let's talk about Apple then first, and then we can get to the specifics. Can someone tell me something specific to Apple?
Upward trend right now.
Yeah, they increase.
It's in a general upward trend. Yep. Anything else? What? Started off being very low. Now you have to be. Let's just get into this now. We have to be very careful when we use words like started low, high, fast. Those are all relative terms. What does it mean by what do I mean by relative terms? Yeah.
Like low to mean.
What does relative? Yeah, it could be interpreted different. But what if the terms are relative? What does that mean? Is hot always hot? Is cold always cold? In comparison to other stocks, or in comparison to? Okay, for example, to Google. Google losing $1 billion. That's bad, right? To a 10-year-old losing $10, that's even worse. To a 10-year-old. Why? How much is a 10-year-old worth? Probably not much more than $10. So if a 10-year-old lost $10, they'd be losing what compared to Google losing $1 billion? Google lost way more money, but
Like, the case wasn't everything like
yeah, the kid lost everything, and Google lost only a fraction of what it's worth. So what's an important thing to keep in mind?
Low might not be low for like.
I like that.
Low for
Low might not be low, but things like low and increase fast entirely have to do with what? Opinion of the people. But again, Google losing $1 billion isn't the end of the world because why? They're worth more. So when you lose a certain amount of money, it more has to do with not the amount of money, but what? Percentages. Thank you. When you look at stock tickers, the things that roll by, what do you see? Things go up a point, down a point. What does that mean? Percentages. Right. Percentages. You know, if a stock is worth $10 and it goes up 10 points, it went up 10%. So it went up $1, right? If Google goes up 1/4 of a point, how much money is that? Okay, well, Google, 1/4 of a point. What is Google stock worth right now? $600? What's 1 point? What's 1% of $600? $6, right? 1/4 of a point is going to be $250, right? 1/4 of a point of Google is worth more than 10 points on a $10 stock. Do you understand what I'm saying, everybody? So it has to do with percentages. It's a big deal. Sorry, if it was 10 points on $10, you go up $1 because it'd be 10% of $10, $1. But if you had 1/4 of a point on $600, what is that? $1.50? Sorry, $1.50. It's still more, right? But it's 1/4 of a point as opposed to 10 points. So is it really important to frame things properly? Yeah. Did anybody do any numeric analysis? Did they look at any numbers? Did they try to model? What did you come up with? What did you do? Some of you did. I saw graphs. What did?
Came up with for Apple, the most lucrative year to invest was in 2009. When
I love that. Yeah. Yep.
213% increase in value.
213% increase in value. Did I tell this class about that website yesterday? There's this website this guy wrote, and I really should just find the link so you guys can see it. That it's just a calculator. It's really simple. It says if you had invested a certain amount of money in Apple at a certain date, how much would it be worth right now? And the basic idea is instead of using dollar values, if you instead of buying that Apple computer, you would put it into stock instead, how much would that stock be worth today? Essentially answering the question, would you make more money buying the computer and selling it now, or what's worth more money? What gets you more money? It's hard to compare because like I can't do my job without that MacBook, right? But if instead of spending $1,000 on that MacBook 3.5 years ago, if I put $1,000 in Apple, what's worth more over time?
stock.
Oh my gosh, the stock. The calculations are ridiculous. Like if you had bought a pretty significant Apple computer in the late 90s or mid 90s, you know, what would a decent computer cost in the mid 90s? What do you think?
500.
No.
No.
When I bought my first computer, it was a middle of the line model. It was in 1997. It was a Gateway P200. It was $2,700, right? So let's say you spent $2,000. Would it be totally abnormal to spend $2,000 on a computer? Not really. Not even today, right? $2,000 on a computer. If you'd done that 15 years ago, the calculations are ridiculous. If you put $2,000 in Apple stock 15 years ago, it's worth $50,000 now. Something totally ridiculous. It's hard to compare exactly because you can't do your job without that thing. You need a laptop, right? But the point is, why, if you had to choose right now between investing in Google and investing in Apple, which one would you invest in? And this is, you can go either way on this. Where would you invest?
Apple.
Why?
Apple had no decrease in 2009.
Steady increase. So it's a steady increase, but more importantly to you, someone said it first when we were talking about this. It seemed more, not just a steady increase, it was more steady overall. So there seems to be less what involved in investing in Apple? Less what? Less risk. So when you're modeling the stock market to predict where to put your money, is it as simple as just looking at their overall price of their stock? Not really. It's a good indicator. If a company's been doing this for a long time, is that a pretty good indicator? But there are other things that you need to think about when you're modeling. You're coming with a model that helps you make a conclusion, especially about stock. What else do people look at when they're figuring out if they're going to invest in a company? I'll give you a hint. Recently, Verizon stock just shot pretty significantly up. Why did Verizon stock shoot up?
They have
iPhone's coming out. Has the iPhone hit the iPhone market yet? Is the iPhone on Verizon yet?
No, but when it does.
So what am I talking about? Potential gain. You know, is there a product coming out? Market research. You know, exciting new things are happening. So it's more than just the numbers at the time. What about Google though? What about Google? Why would you invest in Google? Okay, it might be a little bit more risky. I mean, it's still a pretty good investment, everybody. It's still a good investment. Why might you invest in Google over Apple?
the value is huge.
Could make way more money. A little bit more risk maybe, but more gain. The other thing is, if stock, you know, it's deceiving. It's, you know, the Google stock is worth 600 a share, and Apple stock is worth what a share right now? What does it say? What?
3.1.
341. So like $350, $600. So you're like, oh wow, Google. What do you need to know in order to figure out how much a company is worth? Not their stock price. What do you need? Their stock price and what? Okay, so if I buy one stock in Google, $600. Right? If I buy one stock in Apple, it's $350. Does that tell what? Not how many investors, how many shares? Anybody see the Social Network, the movie?
Yeah.
So they screwed that guy, Zavarian, what's his name? The friend, the initial CFO. Totally true. The stuff they made up in that movie was the stuff that wasn't important to make it a little bit more interesting. Like all the women in it are pretty much made up. Like he's had a girlfriend for 7 years. You know, it's all made up. But the key stuff went to him. He got really angry, right? They screwed him over. How did they screw that guy over in the movie?
They stole his idea.
Well, no, we're not
No,
talking
no,
about the
no,
stealing ideas. Not the Wenceslas brothers, whatever.
That's the brand.
His best friend,
Oh,
who in the end comes in and he thinks he's getting, you know, it's a good meeting, and he gets really angry, and so it leads to the lawsuit.
His percentage of stock.
Why? What did they do? What did they do to a share?
They lowered it.
He had the same number of shares. They diluted it, right? They added a ton of shares, but they didn't dilute everybody's shares. So it was like if we all owned a company, right? And everybody had like 5% of the company, right? And we added 1 million more investors. But instead of evenly dividing up everybody else's shares, we just divide up mine. So how much value do I have all of a sudden? Way less. He went from something like 30-something% stake to 0.03, right? Do you know what a 30% stock in Facebook is estimated value right now? $3.5, $4 billion, right? Something like that. Just think about it. So anyway, you know, read your paperwork. But that's an interesting example. So you need to know the number of shares. Oh yeah, that's absolutely true. That's not in doubt. What? It depends. Well, no, we're not getting to that. I mean, sure. I mean, it depends on how you the most of that is true. I mean, are people sleazy when they're in college? Surprise! Anyway, should see it. It's interesting. Yeah, and Oscar nods. They just yeah, it did. He got Best Actor nomination, right? I think he did. Yeah. So let's talk about a few more models. Let's go to this. So we're gonna go to these pictures right here. So we've looked at linear models, we've looked at quadratic models, cubic. So power functions. Here are power functions. They're actually pretty simple. You've seen them before. Can you hit the lights? All of those power functions have what in common? There's two major things they all have in common. What's one thing they all have in common? They're all exponents. X to the first, x squared, x cubed, x to the fourth. They're all positive integer exponents. Sure. They're all odd or even. Yeah, very good. I like that. What else? Or that's not a sentence. They all pass through the origin. Thank you. Origin. Purple. I don't know what you're saying. They all pass through the origin. That is correct. These curves behave a little differently, so sometimes some of them are better at modeling certain situations than others. What other kinds of power functions could you end up looking like? Well, here are even-powered power functions. They all pass through what points? 1, 1, and 0, 0, 1, 1, and negative 1, 1. Because what is 1 to the 10th? 1. What's 1 to the 100th? 1 to any even power is negative 1 to any power is. So you're always going to pass through those points. What changes about the functions, though, as you increase the exponent? As the exponent gets steeper and steeper, what happens to the graph? Here's x squared. It gets, what would you? What would that? What it gets narrower. Another way to say it, the hill gets steeper. It gets steeper. Grows faster. What about odd functions? Similar. They go through 0, 0, and 1, 1, but instead of negative 1, 1, they go through negative 1, negative 1, because negative 1 cubed is negative 1. Negative 1 to any odd power is, again, the only thing that changes as you increase the power is what? How steep it is. That's it. What happens if we change it to fractional exponents? An even so what's the invisible exponent right there? 2. It's a 2. The exponent is to the 1/2, but the invisible number out front is 2. So an even root to the 1/2, to the 1/4, to the 1/8, to the 1/6. All of those graphs look like this. All of the odd to the 1/3, cube root, 5th root, they look like sideways, like cool S's. You've actually seen a graph that looks like that before, but not a cube root. Have you seen that before? What was the last math class you took?
Trig.
That is a trig graph you've seen before. This looks exactly, very similar to a trig graph you've seen. I'll give you a hint, not sine, cosine, or tangent. It's related to tangent.
Cotangent.
Is it cotangent? Close. Inverse tan? Okay, your homework tonight, everybody. I'm going to clip this in right now. Your homework is the homework and the classwork that's listed right here. Oh, let me get a different one. Sorry. Here's your homework right here. Please do those. From homework packet 3 and homework packet number 2. I'll put these into your notes as well. Okay, get out of here.